Hello, I'm Oscar Garcia from GOMRI Mapping. I'm here at the MC20 oil spill site. I'm working with Dr. Billy Corafalu from the University of Miami for the Gulf of Mexico Research Initiative. We are studying how the influence of the Mississippi River affects the travel of the oil from the MC20, or also known as oil spill from Taylor. Here I'm using a drone with a thermal camera, and Riley, if you can step up here, maybe you can see it. I'm going to ingest the video of the thermal camera. I'm going to bring the drone closer. Okay, so right now we're using the thermal camera from the drone to help us to position ourselves where the thick oil is. The drone is, well, maybe the camera is not going to see it. I am about 100 feet high, and now I'm getting a very strong signal here with the thermal imagery, so you can sort of see it. I'm going to impose it there. But this is what I'm using to position myself on the areas where the thickest oil is. Certainly, I didn't expect to see this much. You can see here where the boat is, how we're moving to get it closer to this thicker area, and that's what we are using to position ourselves on the best spot. As you see here on the video, we're getting closer. We're about to ride there. So right now, actually, we can smell it. And if you can, Riley, if you can take a video of the oil there. We just stop on an area where I believe it's around 50 microns thick oil. Maybe you cannot see it on the camera there. I'm going to recover the drone, and I'm going to start taking samples. This is a sample of very fresh oil that's just got to the surface, and it's in the process of getting the emulsion being formed. As you can see, there is some bubbles entrapped on the oil. So what that means is that there is still fresh gas coming out on this area, and as wind are picking up, we will start seeing how this patch becomes more and more emulsified. And this patch, actually, if we follow it, it's going to become a very dense mousse. Definitely we should pick this signature on the satellite. We are recording now. Actually, 2 hours ago we got the image from EO1, which is an hyperspectral satellite, and as you can see, the sky is completely free of clouds, so we should definitely get a very good picture of this oil. More consolidated emulsion. It's getting a lot more stable. As you can see that patch, if you can point the camera there, yes. That change of color, brown and reds, that means that the emulsion is getting consolidated, a lot more stable. Contrary to this here, what you have here, this is a lot more fresh oil. As you can see clearly, is completely dark. So I'm going to show you more examples of emulsions. Okay, the difference between an emulsion and the fresh oil is that the fresh oil dissipates more rapidly than the emulsion. The emulsion, once it starts forming, it starts converting more and more oil. Actually, you can see it here. You see the black and surrounded by emulsion. The emulsion is getting formed on the edge of the big patch because it's getting the action of the waves, and it's favoring the process of the emulsion formation. So what that means is that you are more likely to find a much thicker oil when you have an emulsion than when you have fresh oil. The fresh oil still tries to dissipate, and the emulsion stays.
So you're looking at emulsion as an indicator of a thicker slick.
That is exactly right.
Okay.